All right, guys, you ready to get started? Oh, didn't mean to do that. I'm gonna just look super quick at the schedule. Maybe I can't here right now. So we have lunch from 12:15 to 12:45. Okay. All right, so we're gonna go ahead and get started here. Just have to share this again. Okay, so today what's going to happen is they're going to explain a graph, and from that explanation we have to go ahead and graph something. So there's a couple of different things that they could tell us. One is they could tell us what the x-coordinate is, and your x-coordinate is going to be on your x-axis. So maybe they tell you that x is 2 or something like that. The y-coordinate is going to be where your graph crosses the y-axis. They could tell you that. They could say to you that your graph is positive for x is greater than 2, something like that. So if it's positive for x greater than 2, that means at 2 your graph would be above the line, and below 2 your graph would be below the x-axis. Okay, so it's positive here, negative down here. If it says that your graph is negative for x less than -3, okay, that means it would be below the axis here, and if it's a straight line, it would be above the axis over here. Okay. If they say that your graph is increasing, that just means that it's going up from left to right. If they say that it's decreasing, that means it's going down from left to right. And then the end behavior, that's what we did yesterday, but they might say to you in sketching the graph, they might say, as x approaches positive infinity, f of x approaches negative infinity. And then they might say, as x approaches negative infinity, f of x approaches positive infinity. Let's just say. So that means as it goes to positive infinity, it's going to be going down. And as it goes to negative infinity, it's going to be getting bigger and bigger. So it could look something like this. It doesn't have to be a straight line, but that would be a situation where as your x gets bigger and bigger, your graph goes down to negative infinity. As your x goes to negative infinity, your graph gets bigger and bigger, which is positive infinity. Okay? So let's go to our first example here. And today you're going to have one of two scenarios. One is going to be where it says that you have a linear graph, and others are going to say it's non-linear. Okay? So this one is linear, and it says that the y-intercept is at 2. So at 2, you're going to put a dot. And then it says the function is positive for x less than 7. So that means something is going on at x equals 7. And this is a linear graph. So if you have 2 points, that means your line has to go through those 2 points. So if we connected these in a straight line, because they tell us that this is linear, and now we look back to see, did we cover everything? It says the y-intercept is 2. The function is positive for x less than 7. Positive means the graph has to be above the x-axis, okay? And it is. And the function is decreasing for all values of x. This should be a straight line, but it is decreasing for all values of x. And then as x approaches infinity over here, this is going to keep getting smaller and smaller. So it is going to approach negative infinity. And as x approaches negative infinity, notice this graph is going to get bigger and bigger and bigger, so it approaches infinity. Okay? All right, so now let's look down here, and again, we have a linear graph. So it says the x-intercept is 4, which is right here. And then it says the y-intercept is at -3. The function is increasing for all values of x. And actually, when they tell you something is linear, if you know 2 points, you can automatically draw a line through there. And remember, I have rulers up here. So we can automatically just draw our line. Because this is linear, that means you're going to have a straight line through those 2 points. Okay? And then you can go back and read it. So the x-intercept, I did this wrong. Did you guys notice that? Sorry. Did I do this one wrong too? Please tell me no. The y-intercept is 2. No, we're fine there. Okay, sorry. The x-intercept is 4. That's right here. The y-intercept is -3. So it crosses the x-axis at 4, the y-axis at -3, and then if we draw a straight line as best as I can here. Okay, now if we go back over and read this, the function is increasing for all values of x, and it is. It's getting bigger and bigger as you go. The function is positive for all x greater than 4. And positive means it's above the x-axis. And as x approaches infinity, notice our graph is getting bigger and bigger, so that approaches infinity. As x approaches negative infinity, notice our graph is getting smaller and smaller, so that approaches negative infinity. Okay? All right, so now let's look at this one. It says use the given key features to sketch a linear graph. The y-intercept is 2. The graph is linear. The function is decreasing for all values of x. So what that means is like your graph is going to be going down for all values of x. Okay, from left to right, it's going down. The domain of the functions is from -2 to 4. So here's what this one is going to look like. 4 from -2 to 4 is where our graph exists. Only from -2, from x equals -2 to x equals 4 is where our graph exists, okay? And then it says, so remember domain is always your x's, range is always your y's. So the range is on your y-axis, that goes from -2 to 4. So you go to your y-axis and at -2 draw a horizontal line, and at 4 draw a horizontal line. Okay, so what this means when they give you like the range or the domain and the range is our graph is only going to fit in this box here, which is restricted by the range values and the domain values. And what it says is our graph goes from, so what I'm gonna do is I'm gonna just draw our line through here. I went through that y-intercept. It's linear, so I drew a straight line. It's decreasing, so I made sure it went down. And then for the domain, it's only drawn from -2 to 4 on our x, and the range, it's only drawn from -2 to 4 on our y. Everybody understand that? Okay. So now let's look at this one. We have another linear graph, and it says the y-intercept is -5. So you're going to go on the y-axis and go to -5. And then it says, as x approaches infinity, our f of x approaches infinity. So does that mean our line is going up or down? If as x gets bigger and bigger, f of x approaches infinity, is our graph going up or is our graph going down? Up, okay? Then it says, as x approaches -infinity, our graph is going down to -infinity. Now, one thing they do not do in this problem is they don't give us a second point. They only give us one. So what that means is when you go to draw your line, you can draw it at any slope, okay? The only thing we have to do is we have to draw it going up on the positive, and then it's going down here, okay? So the key for this is the slope can vary, but it has to be positive. It has to be going up from left to right. Questions on that at all? Okay. All right, now if we go here, we're going to talk about nonlinear functions. And for what we're doing, Non-linear is either going to be like a parabola, like this or this, or another way you can draw some of these is as a V-shaped graph. So it could go up or it could go down. So most of your graphs on these are going to be a parabola or like a V-shaped graph, okay? So what they could tell you here, if they tell you it's continuous, that just means that it's going to have a smooth curve. There's going to be a curve through it. They might tell you a maximum value or a minimum value of the function. And then they also may tell you that something has reflectional symmetry, and that would be like, this would be reflectional symmetry, that would be reflectional symmetry, okay? All right, so it says similar, sketching the graph of a nonlinear function is similar to sketching the graph of a linear function. First, plot points known as your known key features, and then draw your lines or curves to connect these points if it's continuous. So here it says it's continuous, so that means through our points we have to have that curve. The graph is nonlinear, which means that it's either going to be that V shape or the parabola. And they tell us my y-intercept is 2. So I go on my y-axis to where it's 2, okay? Now, they tell me that my graph is positive from where x is -1 to where x is 7. What that means when it says positive, that means between these 2 points, my graph is going to be up above the x-axis. If it had said negative, that would mean my graph was below. Then it says the function has a maximum at over 3 up 1, 2, 3, 4, 5, 6. Okay. So now what you would do is you just have to think about, I'm either going to have like an upside down parabola or an upside down V. And this one, I don't think you could draw a straight line that goes through all 3 of these points. So it looks like it's just going to be an upside down parabola. Okay. As far as where do you draw these 2, you just guess. So this has to go through at -1. This has to go through at x equals 7. But down here, you're not really sure how wide it's going to be, so you just kind of guess. Okay. Now here it says we have a linear function again. The y-intercept is 4. The function is continuous. The function is positive for all values of x. So what that means, my graph has to be up here. It can never be below the x-axis. And it says the function has a minimum at 0, 4. So what that means is this is the lowest point on my graph, okay? The y-axis is a line of symmetry. So there's a line of symmetry over this. And as your x approaches infinity, your graph approaches infinity. And as your x approaches -infinity, your graph approaches positive infinity. Okay, they both go up. So your graph on this one, you don't really know how wide it's going to be. The only thing that you know is that it's going up, and it could either go up as a U or as a V. Okay, there's really both of those ways work. So you just kind of choose which one you want. Okay, so just do this super quick because you can either do the V or And you also don't know how wide to make it, so you just kind of guess. All we know is it's got to be symmetrical, so try to have the same distance on both sides. We don't know how wide it is. Or what I could do, if I wanted, is I could have drawn this as a V-shaped graph. Just make sure it's symmetrical over the y-axis. Does that make sense? Okay. All right. So now let's look here. It says the y-intercept is -3, right here. The graph is non-linear, so either a U-shape or a V. The function has no x-intercepts, okay? If I have a graph that doesn't cross here, where does it have to open? Would it open up or would it open down? Down, right? And then it says that as x approaches infinity, our graph is going to approach -infinity. As x approaches -infinity, our graph is going to approach -infinity. So all we really know here is it opens down. We don't know how wide it is, and we don't know if it's a U or a V, so any of that can work. So you can just kind of judge or guess like how wide it is and have it open down. And that's when you have it as a U, or you could have it as a V. And both of those are correct. And as far as how wide your V is or how wide your U is, you just guess on that part. Okay. Now let's look at this. We have the graph is non-linear. The y-intercept is at 2. The function is decreasing for all x's less than at -2, okay? So I know my graph is decreasing over here. The function is positive for all values of x. So what that means is my graph is above the x-axis, okay? Then it says the function is increasing for all x greater than 2. Okay, and then it says as x approaches infinity, over here our function is going up to infinity. As x approaches -infinity, our graph is going up to infinity. So this is what I would say. We're going to flatten out from here to here. From -2 to 2, we're going to say that's just a flat line. And one of the things they said is that our graph is decreasing for all x less than -2. So decreasing means it's going down. Then it's increasing for all x greater than 2. So that's how I would draw it. Okay. And I wouldn't do a U shape on this one because of the fact that with this one, when you have that flat part, you wouldn't do a U's on it. So because this is a straight line, I would do straight lines there too. All right, I think what I am going to do is skip these two. And then I will shorten your assignment and get rid of the ones that are like this. Okay? So let me look at this. I think one or two of them are that kind. So I will. Did you guys think it was hard? No? Okay. Similar, right? So 1 through, because you were gone yesterday. I see what you're saying. I should give you the note packet and then you can go on and watch the video, but a lot of it is like as x approaches infinity, what does f of x do and so on.
Okay. What time do we go to lunch?
At 15, so right now.
Yeah.
And then I need to get you guys a regular sheet of graph paper after lunch.